Welcome back to the physics show. I don't know that that's how I would introduce my own physics show, but for this video it is. This video is going to tackle activity B of the distance versus time graphs Gizmo that you guys are working on. In activity B, we are looking at runner direction and their speed and how that's portrayed on the graph. So as always, make sure you read the Get the Gizmo Ready part. It says click the red reset button to reset the stopwatch. The graph, I think we're just gonna leave it as is for right now. So the instructions say, run the gizmo several times with different types of graphs. Remember, the red points on the graph can be dragged vertically, so just up and down. You can't move them side to side. So pay attention specifically to the speed and the direction of the runner as we manipulate the graph. So I think, you know what, on your graph, let's go ahead and just reset this so that you only have 2 points going right now. And then let's take a look. So direction of runner. Right now, it is, if we press the green button, the runner is running forward, and notice that our graph is moving upwards, right? Because as time is going on, the distance from the starting line is getting further and further away. Like, that makes sense. How could we get it though so that the runner like reverses direction and runs backwards? Well, if we think about that, if we want them to run backwards, we want them to start at 40 meters, so that way when they end at 0 meters, right? So we can check it. If I press the green go button, does that mean that they run backwards? Yeah, it does. So that should kind of help you figure out what's going on with questions number 1 and 2. In questions 1 and 2, you do have to create a graph and kind of sketch your graph on the diagrams there. So I'll show you what that looks like. The first question was asking you, how do you get a runner to run forward? And remember, we said if we want them to run forward, they start at 0, they end at 40. And so our graph is sloping upwards and to the right. If I want to copy that onto this diagram, then I have to click the picture of the graph, click edit, and then you have to zoom in. Okay, so there's a magnifying glass. Click that, zoom to like 200, make it big, and then you have to kind of find your graph again. Oh, there it is. Okay, so we just want to put a line that shows if you're moving forward, the graph is sloping from 0 and then up and to the right. So here's my line, start at 0 and up and to the right. Just like that. I can change the color of it. I'm gonna make it pink. And I can change the width of it really thick. And then once I'm done, make sure you click this arrow button. Okay, so that way if you want to click and drag stuff across your graph, you're not like adding lines all over the place. And if you're happy with it, if you want to like readjust it, whatever, that's good. Click save and close, and then that should show up on your picture. All right. The second one was going backwards. So remember, backwards we said, well, we want them to start far away from the starting line and then end at the starting line. So you have to flip-flop your graph there. And then you do the same thing for that graph that's next to number 2. Okay. Now, question number 3 is kind of the challenge part of this. It says change the number of points to 5. Okay, so we're going to do that first. Hit enter. Okay, so now we have 1, 2, 3, 4, 5 data points that we can change. Remember, those data points we can only change up and down. We cannot change them left and right. It says create a graph of a runner that runs left to right for 1 second, takes a rest for 2 seconds, and then continues running in the same direction, meaning from left to right again. So let's kind of think about that. If we're running from left to right, that means from the starting line to the finish line, then we want our graph to be sloping up and to the right. So I need to drag this first data point from 0, and then I need my graph to be sloping upwards, right? Just like we saw in, I think it was number 1. But how many seconds is that person running that way? It says they run left to right for 1 second. So that means from 0 to 1 second, they are running forward. Now, how far they run in that 1 second, I think that's kind of up to you to decide what you'd like, but it doesn't really matter. Maybe they sprint, they go very fast, I mean, whatever. Then it says that they rest for 2 seconds. Now imagine that you are the person who is running. You run forward really fast, and then for 2 seconds you rest. Is your distance from the starting line changing at all when you do that? Are you getting farther away? Are you coming back towards the starting line? Or are you just staying put if you're at rest? If you're resting, you're probably just standing in one spot, and they do that for 2 seconds. So we need to make sure that the distance, whatever distance we chose, is the same for those 2 seconds, right? So let me recap the story so far. From 0 to 1 second, the person's running forward. They rest for 2 seconds, so the distance stays the same. And then to end the graph, they continue running in the same direction. So I need to push this last point upwards so that eventually they end at the finish line at 40 meters, and it's the same direction, meaning from left to right. So let's just double check it. Let's see if the graph matches what actually happens in the story. I'm going to press the green start stop button. 1, 2, and then they keep running forward. Perfect. So it matches the story. If yours doesn't, you need to go and check yourself. Okay. All right. So that kind of helps you out with question number 3. Let's go ahead and question number 4 you should be okay with. It's just a general pattern. Let's go to question number 5. It says, with number of points set to 3. Let's drop that down to 3. Create the graph shown at the right. And your graph should include these points. 0, 0. So the first one is at 0, 0. The next one is at 2 and 10. And then the next one is at 4 and 40. Okay. It says, part A, where does the runner start? So remember, that's where you look at your y-intercept, where the graph crosses over the y-axis. That's where your runner starts. Where will he be after 2 seconds? So you look at time is equal to 2 seconds, go up until you hit that line, then go over to the distance. That tells you the distance that runner is at after 2 seconds. Then where will they be after 4 seconds? Same idea. When time is equal to 4 seconds, go up till you hit your line on your graph, and then you go over to the distance, and that tells you the distance after 4 seconds. Okay. It says, in which time interval do you think the runner will be moving the most quickly? Do you think they're going to be sprinting during this first chunk here between 0 and 2 seconds? Or do you think they're going to be sprinting during the second chunk from 2 to 4 seconds? So you have to kind of make a hypothesis. Doesn't matter if you get it right or wrong, but it says highlight your answer below. So do that. And then once you do, you're going to test your prediction. Click the start button and see what happens to the runner during those 2 intervals. Okay. Now, let's go ahead and go to question number 7. 7 says that speed, which is one of our vocabulary words, is a measure of how fast something is moving. Remember, we said that it's the amount of distance an object travels in a certain amount of time. So to calculate speed, you would divide distance by time. Let me see if I can write that equation very quickly on a piece of scratch paper for you. So that way you can kind of visualize it in your head. Here it is. Speed is equal to the distance divided by the time. All right. So let's use that to kind of answer some of these questions. Part A says, in the first 2 seconds, how far did the runner travel? Well, when time is equal to 2, distance is equal to 10. So they traveled 10, what's the unit? Meters, 10 meters. In this time interval, how far did the runner go each second? Well, you can go back to the graph and you can look. If you looked at time is equal to 1 second, it looks to be about halfway between 0 and 10, so it's about 5, right? So they traveled 5 meters in the first second, and then they traveled 5 meters in the second. So in this time interval, what was the runner's speed? How much distance did they travel in a certain amount of time? You would follow this equation. They traveled 10 meters in 2 seconds. So 10 divided by 2 is 5. So they traveled 5 meters per second. Notice how they write it here m/s, meters per second. So then it says, look at the last 2 seconds represented on the graph. This one I'm not going to go through as detailed. You can use the first question to kind of help you get the answer. But you want to look at what's the total distance that was being traveled within those 2 seconds. But here's my hint. Here's what's different. If you say that the runner traveled 40 meters in that last 2 seconds, you would be incorrect. Why is that? Well, from the last 2 seconds, they started at 10 meters and then they ran to 40 meters. They didn't start at 0 meters. They started at 10 meters and then they traveled to 40 meters in those last 2 seconds. So the total distance is just 10, 20, 30 meters. Total distance is 30 meters, not 40. And the time, again, is 2 seconds. It's just this last part of the graph there. Okay, so use that to help you with question number 8. Then it says in question number 9, click the reset button. So that's the red one there. So reset. Experiment with a variety of graphs focusing on the speed of the runner. So in general, how can you estimate the speed of a runner simply by looking at the graph? So here's my recommendation to you. I would switch the number of points to 2. And then I would just mess with how steep the line is. If it's very shallow like this and I click play, how is that different than if I make it very, very steep and I click play? Okay, so that's my advice to you on question number 9. Hopefully you get it, but we'll go over a lot of these big answers when we meet back together in the afternoon. If you got questions, come to office hours. Otherwise, we'll catch you on the flip side.